Okay, so today's lesson we're going to do exercise 10C, division of polynomials. From the couple of lessons before, I mentioned that you need to know your long division, the long division algorithm for integers before you know how to study the division of polynomials. So I'm just going to demonstrate how do we divide the integers first, okay? And then we can move on to the long division for the polynomials. All right, so firstly, let's just start with one simple example. 167, just random numbers here, divided by 12, okay? So the algorithm itself here is, firstly, you need to create a division like this. We're using long division here. So before we actually start with the long division, you do need to know each of the numbers, the name of each of the numbers. So that number 12, as you can see here, that number 12 is actually called, just highlight this one here first, okay? Number 12 here is called the divisor, okay? The divisor here. Number 97 is called, sorry, number 67, not 97, 67 is called the dividend. Okay, all right, and then obviously we need to do the questions, and the answer we have from here is called a quotient. And then if we have a remainder, then the number it's remaining is called a remainder here. All right, so how do we do this question here? Firstly, what you need to do is you look at the numbers here on the sides is 12. Okay, this is 167 here. So obviously one, it does not go to the 12. You need to pick 16. So 16 divided by 12. Okay, so what number goes to basically which number you need to times to 12, that gives you a very close number to 16, but less than 16. All right, so the number is obviously 1. All right, if you times by 2, that becomes 24, which is over 16, and you can't you can't let this one happen. So if you times by 1 to 12, that gives you 12. All right, and remember this is a long division, so you actually times by 1 to 12, and you write down the answer there here. And once you finish that, you're just going to draw another line here, and then you need to subtract. All right, when you do the subtraction, you only subtract the first two numbers here. Okay, so 16 subtract 12 is equal to 4, so you end up with 4, and then you just drag the 7 down, so that gives you 47. All right, once you get 47, then the next step is you continue the process. You start with 47 and divide by 12, and you start to find the number that works. Okay, 12 times by 8 is 48. Okay, just 1 over 47, so we can't use 4, so it has to be 3. That gives you 36. All right, and if you do division, that's 11. Okay, so you can continue the process, but if you do continue the process, you're going to end up with like decimal numbers at the end. But if we just stop at this point and we just try to highlight everything we have here, the number here is actually called the quotient. All right, and the last one, the number at the end, which is the number we have remaining, is called the remainder. All right, now this is an extremely important that you do know each of the name of each number here. Reason for that is because if we just try to rewrite this entire expression, entire division here, that 167 is equal to 12, which is the divisor, times by 13, which is the quotient, and then plus 11, and that is the remainder. All right, it's a very important expression that you need to remember. Obviously, people were just saying, hey, that's so it's so simple, right? 12 times by 13, all right, and if we plus the remainder, it gives the numbers inside here, and that's the reverse process of division. Yeah, but the process is actually easy, but you do need to know some symbols, right? Especially when it comes to the polynomials. The 167, we're usually just using px to represent that expression later on it when it comes to polynomials. Number 12 is the divisor. Then we can use the dx. Okay, or some people using ax, dx. Okay, doesn't matter. Okay, I use dx or ax. And then the 13 is a quotient, so qx. And the remainder is 11, and that's rx. All right, and this is the formula. You kind of need to remember this. It's extremely important, okay? And when it comes to long division for the polynomials, this expression here becomes extremely important, and there's so many questions related to this expression or this formula. All right, now let's move on to the actual division for the polynomials. We're going to use the similar method here, but this time it's not in terms of just a number. It's this time it's actually an expression. So you're going to divide a polynomial expression by another polynomial expression. And how do we do the questions? Basically, this is the type of question we're going to get. All right, so let's start with something that's really simple, the standard question, and then we're going to move on to something that's pretty hard later on. Okay, I'll show you a couple of examples to show you different types of questions. All right, sorry. Example 1. All right, so the first example that we have is we're going to divide 2x to the power 3 minus 10x squared plus 15x minus 14. Okay, we need to divide this polynomial expression by x minus 3. Okay, so I'm going to start the process here. Now, the reason I picked this question is the highest the leading coefficient is equal to 2 here. It's not just 1. Also, the highest power is equal to 3, and the power is 3, 2, 1, and 0 at the end. So as you can see here, we have every single term. There's no term that's missing. All right, eventually we're going to do questions where some terms is missing from the expression, and then how do we deal with the case like this, okay? All right, so first step, you're going to draw a pretty long division sign or symbol. You write down 2x to the power 3 minus 10x squared plus 15x minus 14. All right, remember the key of success is you actually write your answers really clear. You set up your working out really, very easy for you to actually read. Otherwise, you will make a mistake. All right, so now the first step. You pick the first term, which is x. Don't worry about the 3, okay? I don't care about the 3 here, just looking for the x. And you're looking for that term here. What you need to do is divide this term by x. Okay, so divide 2x to the power 3 by x. And that becomes 2x to the power of 2. So that's pretty easy, 2x to the power of 2. That's not hard at all, okay? So that gives us 2x to the power of 2. And you write just directly above the term. Do not write here, okay? Do not write in the middle, write above the term here. So remember the alignment is actually really important when it comes to long division, okay? All right, once you finish that, the next step is you times the term here by x and then by the negative 3. And then once you times them, you write your answer underneath it, like here. All right, that's what you do now. So if you times 2x squared by x, obviously that becomes 2x to the power 3. And obviously these two terms is going to be cancelled out. All right, that's the whole purpose. Each time you cancel a term at a time, okay? Eventually you will end up with the term that has the same power here, and then you will have some sort of remainder at the end. That's the idea. So you get 2x to the power 3 minus 6x squared. Okay, so once you finish that, you write underneath it like this, as you can see here, then you subtract. All right, do a subtraction here. As I said before, these two terms must be cancelled out. If they don't, that means you didn't do this one properly, okay? The first term has to be cancelled out. The leading term always cancels out every single time. Now you need to perform the calculation here. All right, so I'll actually remove that negative. Otherwise, sometimes the student get a bit confused about like 2x minus. So we remove that, but you need to remember you are actually subtracting. Okay, so negative 10x squared minus the negative 6x squared. Again, remember your algebra is very important. Don't make any stupid mistake. That's minus 4x squared. All right, once you have finished that, you can now drag the term down. Okay, you can drag the term one at a time if you want, or you can drag both terms down. I just prefer to drag both terms down, so you end up with this. All right, so now, as you can see, previously it's a degree of 3 polynomial. After you perform one division, you end up with degree of 2. So this is the whole purpose. We're reducing the power 1 at a time, okay? Now we perform the calculation again. So repeat the whole process again. There's no difference now, all right? So look at this term. Look at the term here, do a division. That's minus 4x, okay? And then you use this term, multiply by the terms in the front, and then copy it down here. So you're basically, you're repeating the entire process again and again and again until that, the power balanced out, and then you can't divide any further. So that gives you negative 4x to the power of 2 plus 12x. All right, do your subtraction again, 3x minus 14. Now, once you get to this point, pay attention to the power here. That's power of 1. That's also power of 1. So you can still continue to do this question, but that will be the last time you can do it. So you just plus 3. Have you noticed I actually write down always align with the terms there? Very important, always make the alignments, okay? This is extremely important that you actually set up your long division properly. Okay, otherwise when it comes to the terms that's missing, okay, you will get confused. So that's a 3x minus 9, and then you do subtract both terms. That gives you minus 5 here. Okay, so that's it. So what I have here is I've got a divisor, that's x minus 3. I've got a dividend, which is just a px. And then I've got the quotient, that's the remainder I have. That's all. That's the completion of that long division here. All right. So once you have finished that, you can write on the long division process by using this formula one more time. So px is equal to the dx times by the qx, all right, plus the rx. Get used to this formula, please. Okay, so that eventually is equal to, so that px, if you write this one down, all right, the 2x to the power 3 minus 10x squared plus 15x minus 14 is equal to the divisor multiplied by the quotient and plus the remainder, which is obviously minus 5 there. Okay, that's what you do. All right, so this, you don't need to write it all the time. You only write it if the question asks you to do it. Otherwise, you can just, that's your answer here. You can just answer the question by saying, okay, that becomes the remainder. Here is the quotient. All right. Okay, now, a couple of things I do want to talk about in this case here is pay attention to the power. That's something I really want to emphasize here. Have a look at the power here for the divisor. The degree of the divisor here is degree of 1. Okay, and then pay attention to the remainder here. The degree for the x, there is no x here, so that's a degree of 0. Okay, why am I emphasizing this? All right, there will be questions where you're going to use this property where the degree of the remainder is always less than the degree of the divisor. Okay, and that's something we are going to look at it later. Okay, when it comes to factor and remainder theorem. So please remember this. That's the property. The degree of the divisor here is always less than the degree of the remainder, and usually just one less. So if this is power of 2, and that would be a power of 1 linear, equations. If that's a power of 3, that's going to be a power of 2. Usually that's the case. All right. Okay, so hopefully you understand this. All right, so that's example 1. Now I'd like to do another example, and this time I'm going to show you what happens when some terms is missing in the dividend. Okay, that's something I mentioned before. Probably some people are just wondering, what does that mean? Okay, so let's have a look at this question here. We have x to the power 5 plus 3x to the power 4 minus 2x squared minus 3 divided by x squared plus 1. Okay, so when you first look at this question, it doesn't seem to be like, very difficult, right? It's like very similar to the one we just got, right? However, if you really count, that's 5, 4, 2, and where's the 1? Where's the power of 3? Where's the power of 1? They're all missing. And that created a problem. The problem is, when you actually first study this, long division stuff, right? If you're not very skillful or having experience, then you will end up with a problem. If you try to do the question like what you did before, all right, I'll show you what's happening here. So if we just write the terms like this, all right, and then we just perform the calculation. Okay, let's just start here. X to the power 5 divided by x to the power 2, that's x to the power 3. And then we just times x to the power 5 plus x to the power 3. Okay, so have you noticed the problem? If you align your terms like this, all right, these two are not really in the same place. As you can see, that's power 3, that's power 4. You can't cancel them. You just can't, all right? You can't do anything about it. You can't combine the like terms. So when you do subtraction here, you can only cancel these two. For a student that have, experience of this, all right, they can just do the question by writing 3x to the power 4 minus x to the power 3 minus 2x squared minus 3. Okay, so they can just copy the terms here down like here. They can just do the subtraction like this. Okay, but some students, they're not really, I have to say, like, they don't have a very good algebra skills, and then they get confused, all right, and they sometimes making silly mistake. They start to write down 2x to the power 3 or 4. Okay, because they just treat the like terms. All right, so in order for me to, in order for like you guys to solve this little issue here is, try at this stage when you first study to, you know, how to do a long division with polynomial. At this stage, try to fill in the term that's missing. All right, so what does that mean is, you can either just draw boxes, all right, like empty boxes, or you can leave a space. I think in the textbook they just leave a space, okay? They left a space like this, which I find this is really stupid, okay? I don't like to leave a space, okay? So what you can do is you can just add in zeros, okay? You can even add zeros and put x to the power 3 here, all right? If you find this is making more sense. So I prefer this. It looks much better. All right, when you're adding 0, 0 is a number. It should be there. The term is missing, yes, but we still have a coefficient of 0. So that now, it completes everything. So 5, 4, 3, 2, 1, and then that's x to the power of 0. So you do have everything. Now you can perform your long division, and you have every single term aligned. All right, and then later when you have the term underneath here, you can just use 0 minus the term in the front. All right, so I hope you understand what I'm talking about. All right, so once we get this, then what we have here is we're going to have x to the power 3, and that becomes x to the power 5, plus x to the power 3 here. But then here comes another issue, okay? Well, we solved the issue here, but we still haven't solved the issue for the divisor, okay? So if you look at, pay attention to the divisor here, that's x squared, but that's just constant. There's no x to the power 1 there. Okay, so that becomes another issue. So there's another, a few ways you can solve this issue. If you realize there's a term missing, you can actually write down the x to the power 3 there and putting zeros there. Okay, but if you find this is too hard to, to get around, all right, you can change your divisor into 2 x to the power 2 plus 0 x to the power 1 plus 1. That way, like what we did for the dividend, you have an extra terms inside, so you're filling all these extra terms. Now, if you times these two together, you know that's equal to 0. All right? Doesn't matter what the way you're doing, okay? Your job is to make sure that it's easier for you to realize there's a term missing, and you should be able to find the terms, and then now what you need to do is subtraction. All right, so if you align them together perfectly, that becomes 3x to the power 4, and that just becomes what? 0 minus 1 is minus, x to the power 3. That's what you do, okay? All right, and you copy this. And now you can start the process again. When you get experienced, if you ask me what's the way I do it, I just do it straight away. I don't adding zeros there. Okay, I find wasting your time. I just do it with a term there. I know where I need to leave a space. Okay, but this is only after you actually really, you probably just grasp all the content and you understand the concepts here, and you practice a few questions and you know what to do, and you can try to do this without writing zeros. But again, at the beginning, try to do it properly. All right. What am I doing? That's not 4. That's 3. All right. So 3x to the power 4 plus 0x to the power 3 plus 3x squared. See that? All right, once you actually prepare your long division, it's now much easier. So that's equal to 0. No, that's not equal to 0. That's equal to minus x to the power 3 minus 5x squared plus 0x minus 3. All right, minus x to the power 3 plus 0. You can say 0x to the power 2 minus x. That's x minus 3, and that's it. Okay, so now you have a remainder of x to the power 3. Now, comparing to the previous remainder we have here, have you noticed that remainder is like a constant term without x? Just because of that's a degree of 1. All right, remember I said if that's a degree of 2, the remainder usually is going to be a degree of 1. So if you look at this, that's a degree of 2 for the divisor, and the remainder is degree of 1. So that's the property that you do need to know, and it's extremely important. Okay. All right. Okay. So this is the second example when there's some certain terms that's missing. All right. Now I'm going to try a few questions from the exercise. Maybe just 2 questions should be enough, I think. Okay. And yeah, and then we can move on. All right. So I would like to do question. That's a good one. Question 11 from the exercise. So the question 11 says, if x to the power 4 minus 2x to the power 3 minus 20x squared plus mx plus n is exactly divisible by x squared minus 5x plus 2. Now the question asks you find m and n. Now, if you have learned, the long division, factor theory and the remainder theory, don't worry about this question here, but we're just doing it without knowing the, other content, okay? So in this question here, what we need to do is we'll just perform the long division. It says exactly divisible, all right, which means the remainder equals to 0, all right? So that just means that Rx is equal to 0. So once you know this, this property here, we should be able to actually do this question. X to the power 4 minus 2x to the power 3 minus 20x squared plus mx plus n. X squared minus 5x plus 2. Alright, so let's start the long division process. Just checking everything. Power 4, 3, 2, 1, 0, 2, 1, 0. Okay, perfect. Nothing missing. X to the power 2, x to the power 4 minus 5x to the power 3 plus 2x squared. Okay, subtraction. 3x to the power 3 minus 22x squared plus mx plus n. Plus 3x to the power 3 minus 15x to the power 2 plus 6x. Okay, subtraction again. Negative 22 plus minus 15, which is plus 15, is minus 7x squared. Okay, now here comes a bit tricky. Just be careful about this one here. You've got a coefficient of m minus the coefficient of 6. So you actually write down plus bracket m minus 6x plus n. All right, that's the way you do it. Keep going. All right, minus 7. So minus 7x squared plus 35x minus 14. Just have to be very careful with the algebra there. All right, it's extremely easy to make a mistake. All right, so now you're going to subtract these two terms here. So that gives you m minus 41 bracket x plus n minus 14. All right, that's what we have. All right, once we have this, now the next step is actually pretty easy. We need to make sure the remainder is equal to 0. It says exactly divisible, which means this remainder here, m minus 41x plus n minus 14 should equal to 0. And we need to find out what's m and n. All right, so in this case here, the m must be equal to 41, n must be equal to 14. That's the only cases when the remainder is equal to 0. All right, so that's how you do question 11. It is a pretty easy, question there. Okay. Is there any other question that I feel like I need to talk about in exercise? I feel like this example it should be enough for you to actually go through the exercise. Again, have a look at what exercise questions that you need to do. If you have any questions, make sure you post me the questions. I will solve it for you. Okay, that's all you have to do for long division for this exercise. All right, thank you.